Guys, in my previous video, I have explained about what is meant by nodal analysis. So we can apply nodal analysis for planar and non-planar circuit. This is point number one. In order to find node voltages, we need to apply what? KCL. This is point number two. Next thing, how many equations you will get? The number of equations completely depends on what? Number of nodes, n minus 1. If you have 3 nodes, 3 minus 1, you will get what? 2. So you will find two node voltages, that is V1 and V2. Clear. Once if you know node voltages, you can find any other unknown parameter in the circuit. Now when coming to the problem number 2, now you need to find node voltages and the next thing, current at each resistor using nodal analysis. And what is our procedure? For the given circuit, first you need to identify how many nodes we have. Here node means what? Not a simple node, principal node. Now here see, this current source and 10 ohm and 3 ohm resistors are connected here. This is my node 1, so therefore this is V1. Now here 3 ohm, 5 ohm and 1 ohm are connected here. This is my node 2, therefore this is V2. Now can I consider this 1 ohm and 10 volt resistor are connected here? This is my node 3? No. This is simple node. Now can I consider this current ohm here? This is my node? No. This is also a simple node. Clear. Now we need to consider a reference node and that reference node equal to what? 0. For given any circuit, we have how many reference nodes? Only one. Therefore V reference equal to what? 0. Now what you need to do? Apply KCL at node V1 and apply KCL at node V2. Before apply KCL, what we have to consider? We need to consider that current is leaving from the node to the each branch. Suppose here we have I1 current is leaving from V1 towards current source 5 ohm, 5 ampere, and I2 current is leaving from node V1 towards 10 ohm, and I3 current is leaving towards 3 ohm resistor. Clear. Now if I apply KCL at V1, what I will get? As per KCL, I1 plus I2 plus I3 equal to 0. Therefore, how to find I1? See, this is what? A current source. Now what current is flowing entire this branch? Of course 5 ampere is flowing. Now your assumed current direction and this current source direction is what? Opposite. Therefore if it is opposite, I should write minus 5. Same, I should write plus 5. Now here I need to write I2. I2 means what? So one terminal V1 is connected and another terminal of 10 ohm V reference is connected. Therefore V1 minus 0 by 10 ohm plus. What about I3? I3 means 3 ohm. One terminal of the 3 ohm is connected V1. Another terminal is connected V reference and also what? V2. Therefore, V1 minus V reference is what? 0. And another terminal is connected what? V2 minus V2 by what? 3 ohm. So I already explained in my first video that how to write this equation, right? This current of I1, current of I2, current of I3. Clear. Minus 5 plus V1 by 10 plus V1 minus V2 by 3. Now if we do the LCM, what would be the LCM here? 10 into 3, 30. Therefore, minus 5 into 30, you will get minus 150. Plus if I write 30 here, 10 ones and 10 threes. Therefore, this is 3V1. So if I write 30 here, 3 ones and 3 tens. Therefore, 10V1 minus 10V2. Now this is what? Equal to 0. Now if you solve this equation, what you will get? You will get 13V1 plus minus 10V2 equal to what? 150. So if you solve this one, you will get this one 13V1 minus 10V2 equal to 150, and this is my equation 1. Now you need to apply KCL at node V2. Before apply KCL at node V2, what we need to consider? Current is leaving to the each branch from V2. So you already consider I1, I2, I3. Therefore now you consider this is what? My I4, and this is I5, and this is what? I6. Clear. So if I apply KCL at V2, what I will get? I4 plus I5 plus I6 equal to 0. Clear. Now what? How can I write I4? So see here, one terminal V2 is connected and with reference what? 0. Another terminal V1 is connected. Therefore V2 reference is what? 0 minus V1 by what? 3. Now here I5 means what? one terminal V2 is connected, another terminal of the 5 ohm V reference is connected. Therefore, V2 minus 0 by what? 5 plus, see, I6 means one terminal of the 1 ohm is connected V2. So another terminal, this is what reference equal to what? 0. Another terminal is what? 10. This is what? Minus 10 by what? 1 ohm equal to 0. So here I don't know about V2, so I have written V1 minus V2. But whereas here you V2 and you already given voltage source is what? 10, so that I have written minus 10. Therefore, what is the LCM here? So you can write V2 minus V1 by 3 plus V2 by 5 plus V2 minus 10 by 1 equal to 0. Now what is LCM here? 5 into 3, 15. Okay, so if I write 15 here, 3 ones and 3 fives. Therefore, 5V2 minus 5V1. So if I write 15 here, 5 ones and 5 threes. Therefore, 3V2 plus if I write 15 here, 15V2 and minus 150 equal to what? 0. Now if you solve this one, you will get what? Minus 5V1 plus 23V2 and equal to 150. Now see here, you get two equations, right? Equation 1 and equation 2. When you apply KCL at V1, you get equation 1, and when you apply KCL at equation 2, node 2, you get equation 2. Now by using equation 1 and equation 2, you know how to find V1 and V2 by using Cramer's rule. Okay. Now here I am going to write equation 1 and equation 2 one more time. So equation 1 is what? 13V1 minus 10V2 equal to what? 150. This is equation 1. And equation 2 is what? Minus 5V1 and plus 23V2 equal to what? 150. This is my equation 2. Now see here, by using equation 1 and equation 2, so you can find V1 and V2 using Cramer's rule. So here V1 equal to what? Delta V1 by delta, and V2 equal to what? Delta V2 by delta. So once if you know determinant of delta V1, delta V2, you can find V1 and V2. Now you can write delta equal to what? V1, V2 terms from equation 1. So V1 coefficient is 13, V2 coefficient is minus 10 from equation 1, and equation 2 minus 5 is the V1 coefficient and 23. So if you multiply this 13 into 23, you will get what? 299. And now when you multiply down to up, you need to write minus 5 into 10, 50, right? So therefore this is minus 50 equal to, you will get 249. And now delta V1 equal to what you have to write? Instead of V1 terms, you need to write constant values from equation 1 and 2. What are the constant values? 150 and 150. Now V2 coefficients are same, minus 10 and 23. Now you need to find the determinant of delta V1. So if you multiply 150 into 23, you will get 3450. Now when you multiply from down to up, you will write minus. Therefore here 150 into 10, you will write 1500 minus 1500, minus minus will become plus. Therefore determinant of delta V1 is 4950. Clear. Now you need to find determinant of delta V2. Now instead of V2 terms, you need to write constant values. So V1 values are same. So 13 and minus 5. What are the coefficient here? From equation 1, 150, and equation 2, 150. Now you need to find determinant of delta V2. If you find determinant 13 into 150, you will get 1950 minus, when you multiply from down to up, you will write minus. Minus 5 into 150, you will get what? 750. Minus 750, minus minus will become plus, plus 750. Therefore 2700. Now you find the determinant of delta V1 and delta V2. Therefore V1 equal to what? Delta V1 by delta. Delta V1 means what? 4950 by delta equal to what? 249. So if you cancel this one, V1 equal to 19.8 volt. Clear. Now here for V2 node voltage, delta V2 by delta. So here delta V2 means what? 2700 by 249. So if you cancel this one, you will get 10.9 volts. See here, by using Cramer's rule, we find what? V1 node voltage V1 and V2. Now the first thing is completed. The next thing, by using this node voltages, you need to find current at each resistor. Now see here, I have considered this is my V1 and this is my V2. So here I have considered this is I1, I2 and this is my I3. Yes or no? So therefore I1 equal to what? You no need to find here. I1 equal to what? 5 ampere. They already given. So here I1 equal to what? Current at this branch is what? 5 ampere. No need to find. Now current, what is the current at 10 ohm? So current at 10 ohm equal to, you need to write V1 minus 0 by what? 10. So you already know V1 node voltage 19.8 by 10. So if you cancel this one 19.8 by 10, you will get 1.98 ampere. So what is the I2 current at 10 ohm? 1.98. Now what is the I3 current? See here, in order to find I3, so current at 3 ohm equal to what? You can write V1 minus V2. V1 minus V2 by what? 3 ohm. So of course you will write minus 0. So it doesn't change anything, right? So you already know V1 and V2 value. If you submit here, current at 3 ohm equal to what? 2.99 ampere. Now you need to find what? Current at 5 ohm. So let us consider this is what? I5. So current at 5 ohm equal to what? You will write V2 by what? V2 by 5. So here V2 by 5, you already know node voltage 10.9 by 5. So if you submit that one, you will get 2.18 ampere. So this is what current flowing at 5 ohm resistor. Now what is the current flowing at 1 ohm resistor? So you can write current flowing at 1 ohm resistor equal to V2 minus 10 by what? 1. So of course you will write minus 0 here. It doesn't change anything. So once if you submit V2 equal to what? 10.9 minus 10. Okay, by 1 means you will get 0.9 ampere. Now see here, once if you know node voltages, you can find current flowing to the each branch. Once if you know node voltage and what current flowing, then you can find power at any branch. So here node voltage is what? Very important. I hope you understood how to solve this one. So I will explain one more time. See here, for the given circuit, you need to assume, you need to consider, identify what? Node voltages. So here you have two nodes V1 and V2, one reference equal to 0. Now you need to apply KCL at V1 and V2. You will get two equations, 1 and 2. So if you solve equation 1 and equation 2 by using Cramer's rule, you can find node voltage V1 and V2. So once if you know node voltage V1 and V2, you can find current at any branch in the circuit. So I strongly recommend you to watch Cramer's rule. How to find V1, V2 for 2 by 2 matrix. How to find V1, V2, V3 for 3 by 3 matrix. Okay. So if you know this calculation, it is very easy to find what? Node voltages. Okay. Thank you. Thank you so much.